Special relativity is one of the most mystified concepts of physics that has changed our understanding of the universe. This theory applies only when the observers are in an inertial reference frame, which means the body is either at rest or moving at a constant velocity in a straight line. According to special relativity, laws of physics are same in all inertial systems, and speed of light is a constant 3 lakh kilometers per second, irrespective of the motion of the source emitting it. So even if a spaceship traveling at half the speed of light emits a light beam, the light would still be traveling at 3 lakh km per second rather than 1.5 times the speed of light. This is because the light travels as a wave. By the Doppler effect, if a light source moving towards you emits light, the speed of light would remain the same, but the wavelength would decrease, and so the light would shift towards the blue spectrum. Special relativity has many more peculiar outcomes like time dilation, length contraction, relativity of simultaneity, etc. Time dilation is necessary to keep the speed of light constant. Imagine a train running past an embankment. Observers A and B are on the train and embankment respectively. Both have identical clocks in which light bounces back and forth. When light bounces back and forth once, it is called as one observation. Now, according to the inertial frame of B, the embankment is stationary and the train is moving. So according to B, her light ray only travels perpendicular distance, but A's light also has to cover horizontal distance since the train is moving. So it must cover more distance in the same time. But the speed of light is same and the time taken for one observation is also same as their identical clock. The time on the train must run slower with respect to the time on the embankment. This is called as time dilation. One of the most famous examples of time dilation is the twin paradox. Imagine you have a twin. She goes in a spaceship traveling at a constant velocity close to the speed of light, turns around and comes back. When she returns, you have aged 30 years while she has aged only 26 years. How? Just like the train example, you will think you are stationary while your twin on the spaceship is moving and her time is running slower and vice versa. But still the twin on the spaceship ages slower. That's because when the spaceship turns around to come back, it accelerates and hence special relativity no longer applies to it. Now here we have to venture a little into general relativity. According to that, time runs slower in accelerated reference frame, and so time will run at different speed for both the twins during that accelerated reference frame and hence the age difference. So it means there is no absolute time. Through this theory, Einstein showed that if time is relative, so too are space and distance. Hence there is no real or right. There is no way to say that any two events are absolutely or really simultaneous. So time dilation, Doppler effect, twin paradox are just the tip of the iceberg and there's so much more yet to know. This is Anushka Bhatt and thank you for watching.